Hello and welcome. I'm Saeed from storyplanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book, The Laws of Thermodynamics, a creation by Peter Atkins. The Laws of Thermodynamics, 2010, by Peter Atkins, is a concise and easily understandable guide to the principles of thermodynamics, a branch of physics focused on energy transformation. Exploring the fundamentals, it delves into the four governing laws of the universe, zeroth, first, second, and third. Through this, it clarifies concepts such as temperature, entropy, and energy states, both common and abstract. Before we delve into these revelations, it's interesting to note that Peter Atkins, a distinguished physicist, has authored more than 60 books, including the widely used textbook Physical Chemistry. He is a fellow at Lincoln College, University of Oxford, and a popular figure in global lectures. Atkins has been a visiting professor in China, France, Israel, and New Zealand. With 10 key ideas to unveil, brace yourself for a deep dive into this captivating book on storyplanet.net. To start, discover the laws of the universe. The text discusses how thermodynamics, a branch of theoretical physics, governs energy transformations in the universe. It mentions physicist Peter Atkins, explaining the laws of thermodynamics from zeroth to third and their application in various scenarios like boiling water, burning gasoline, and cooling leftovers in refrigerators. The importance of understanding thermodynamics in explaining the workings of our world is highlighted. Key idea number 1. When two systems are in mechanical equilibrium, a third system that is in equilibrium with one of them will also be in equilibrium with the other. Thermodynamics deals with systems and their surroundings. Systems can be open, closed, or isolated. Understanding mechanical equilibrium is essential to comprehending thermodynamics. It involves analyzing pressure and balance within systems, which helps in grasping the core principles of thermodynamics. Key idea number 2. The zeroth law introduces thermal equilibrium and the concept of temperature. The text introduces the concept of the zeroth law of thermodynamics, emphasizing thermal equilibrium and the importance of temperature in understanding it. It explains how the zeroth law establishes that if two systems have the same temperature with a third system, they will all have the same temperature, leading to the understanding of thermal equilibrium. The text also parallels the zeroth law of thermodynamics with the concept of mechanical equilibrium discussed earlier. Key idea number 3. The Boltzmann distribution explains how atoms are distributed among energy levels at a specific temperature. The text discusses the Boltzmann distribution at the atomic level, explaining that atoms are distributed exponentially across energy states, with more atoms in lower energy states. As temperature increases, atoms move to higher energy states. The distribution of atoms across energy states is key to understanding various phenomena and provides a molecular definition of temperature based on how atoms are distributed across energy states. Key idea number 4. The first law of thermodynamics. The internal energy of an isolated system stays constant if no work is done on it. The first law of thermodynamics states that the internal energy of an isolated system remains constant if no work is done on it. Work is defined as motion against an opposing force, and it is related to a system's capacity to do work, known as energy. Energy can be transferred as heat when a system interacts with its surroundings. Internal energy is a property of the system, and different systems have varying amounts of energy. Key idea number 5. Heat is lost to the surroundings during the conversion into work, and energy is required to transfer heat from a cold object to a hotter one. The second law of thermodynamics is explained through the example of a steam engine and everyday occurrences like heating a mug or freezing a beverage. It teaches that heat cannot be transferred from low to high temperature systems without work being done elsewhere, and it emphasizes the importance of the cold sink in the engine's operation. Key idea number 6. The second law of thermodynamics. Entropy of the universe increases during spontaneous changes. Key points. Heat, converted into work, leads to some heat being transferred to surroundings. Heat cannot flow from high-temperature systems to low-temperature systems without work involved. Entropy reflects the quality of a system's energy and is linked to disorder. Entropy of a system changes when heat is transferred, depending on initial entropy and heat transfer size. A metaphor of sneezing in a library, low-entropy system, versus a bustling street, high-entropy system, illustrates entropy change. Lower entropy systems experience more significant entropy changes. Larger heat transfers result in larger entropy changes. The second law of thermodynamics suggests that the entropy of the universe increases during spontaneous changes when heat is transferred without work. Key idea number 7. The second law of thermodynamics explains how cold sinks work and the direction of heat transfers. The text discusses the concept of the second law of thermodynamics in relation to heat, work, entropy, and the necessity of a cold sink in engines to maintain entropy increase in the universe. It demonstrates that without a cold sink, entropy would decrease in an engine, which violates the second law. The text also covers the transfer of heat from hot to cold objects as a spontaneous process and highlights the necessity of work to maintain entropy increase in the universe. The conclusion reached is the successful verification of the second law of thermodynamics. The remaining question to be addressed is the specific definition and significance of entropy. Key idea number 8. Entropy is a measure of the likelihood of finding the energy state of a molecule. Entropy is a measure of disorder linked to the energy distribution of particles in a substance. At higher temperatures, atoms move to higher energy levels, increasing the range of occupied energy states. This leads to more uncertainty about the energy level of individual molecules, representing increased disorder. At absolute zero, 0 kelvins, all particles occupy the lowest energy state, resulting in zero entropy and zero disorder. Key idea number 9. Enthalpy, Helmholtz energy, and Gibbs energy are key tools in thermodynamics for analysis and calculations. The text discusses how heat is like a tax in thermodynamics when converting into work, using concepts like enthalpy and entropy. It explains how systems pay a heat tax when producing work and a work tax when producing heat, following the second law of thermodynamics. It introduces accounting tools like Helmholtz and Gibbs energies to track these changes in thermodynamic systems. Key idea number 10. The third law of thermodynamics. At absolute zero, crystalline substances have zero entropy. The text explains the third law of thermodynamics, which focuses on cyclical processes and the impossibility of reaching absolute zero entropy. It applies specifically to perfectly crystalline substances, which have zero entropy at absolute zero temperature. This law ties together concepts from the zeroth, first, and second laws. It highlights that no finite sequence of cyclic processes can cool a body to absolute zero. In conclusion, the zeroth law of thermodynamics defines thermal equilibrium and temperature. The first law states internal energy in an isolated system remains constant without work. The second law introduces entropy increase in spontaneous changes. The third law says entropy of crystalline substances stabilizes near absolute zero. These are foundational principles in thermodynamics. To delve deeper, consider reading A Brief History of Time by Stephen Hawking for insights on physics' broader landscape. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.